Okay, now we're recording this. Behave. Question number 9. So we are dealing with double integrals here, not single integrals anymore. What we have is dx dy. The first one is dx. Dx is associated with the first integral. So the inner integral is dx. The outer integral is dy. Inner dx, outer dy, right? If it was dy dx, then the inner was dy, outer was dx. Does it make sense? It's just with the order of what's given, dx dy. So if I want to solve this one, I have to define my function. My function is now a function of both x and y. F is at sign x comma y, x dot times cosine of x dot times y. Is that the function? Yes. So that's my function now. For double integral, we have integral 2. Integral 2 of f. Now, the limits or the boundaries for x from 0 to pi over 2, that's the boundary for x. From 0 to pi over 2, that's the boundary for y. So 0 to pi over 2 and 0 to pi over 2. That is my double integral. Is this clear so far? Let me now go to the other one, which is a little more complex. So it goes between 0, so it's again this dx dy. Boundary for x is 0 to 9. Boundary for y is 0 to square root of x. Right? So the upper boundary for y is dependent on x. Let's define this function first. x3 exponential of y3. H at sign x and y is x to the power of 3 dot exponential of y to the power of 3. Does it make sense? That's just a function. The only other thing that I have to define is my y max. The boundary, the upper boundary for y is also a function of x, so I have to define it. Y max is at sign x square root of x. That's what's given. Now we have integral 2 of h from 0 to 9 on the x-axis and from 0 to square root of x, or from 0 to y max on the y-axis. And that's going to be your answer. And the remainder of that question is basically similar, so you don't really need it. I mean, I don't need to solve that for you. All right, so this is a repeat of question number 12 because last time I didn't record it. I wanted everyone to have access to this. So what we are dealing with here is we want arc lengths of parabola which in the range of 0 to a, which is calculated through this integral. We need this function. This f prime represents derivative. We want the lengths of that arc between 0 and 20. So we have two arcs. We need to calculate f prime, or the derivative, for each of the arcs. Now the issue is how to calculate that derivative. You can do it manually, or you can use the symbolic toolbox in MATLAB to do so. In order to do that, let me clear and CLC. Everything is gone now. Sims of x f is, so let me define this function here. F is 3 times 1 minus 3 times 1 minus x minus 10 squared divided by 100. So that's my function f. The derivative is calculated through the function diff. Diff of f, that's my derivative. Now, I can either solve this through symbolic and analytical solution, which is INT, or I can do adaptive quadrature, which is integral. So let's do INT first. My function that goes into INT is square root of 1 plus f prime squared. So I go back here, my function g is QRT of 1 plus f prime squared, and f prime is basically, or derivative is basically this. So that's my function g, which is basically this function within the integral. It goes between 0 and a, so INT of g between 0 and a is 20. That's the length. And since this is a symbolic value, it doesn't really make sense. So I use the function double to change that answer into a real answer, a real number. So that's how we use the analytical solution. For the numerical solution, differential of f again, because I need that function. I define this function as h now, and I define it as a function of xx. That's square root of 1 plus f prime. I need a dot now because it's an analytical solution, and f prime is this value, and it's a function of xx, so I define x as xx, and then I use integral of this h between 0 and 20. That's the same answer as I got before. So that's the numerical simulation, or numerical answer now.